Hello बच्चों, सत श्री अकाल and namaste from my side. So this side, Indrajit Singh welcoming you all right to the most senseful platform that is PW and now expanding into the Middle East as PW Gulf, right? So guys, today is going to be the most important chapter that we are going to deal with the ray optics. Okay, we are going to deal with the what? Ray optics. Lots of practice questions we are going to do. We will try to revise the entire optics through the sums. Okay, because into the minimum time we have to move forward, right? So guys, without wasting our time, let's move on to the, okay, we are going to follow the reverse engineering through sums. We are going to see the each and every concept of the ray optics. Okay, so the agendas of today's lecture will be what, right? The ray optics. Okay, the practice questions and the some of the PYQs of the ray optics. So guys, let's move on to it. The first question that is coming up in front of you in mobile and computer screens, right? The question is from JEE Main 2017. A diverging lens with the magnitude of the focal length 25 centimeter. I think two kind of the lenses are going on. We are discussing about the two type of the lenses, right? The diverging lens with the magnitude of the focal length of 25 centimeter is placed at the distance of 15 centimeter from the converging lens, right? The diverging lens, magnitude of focal length 25 centimeter is placed at the distance of 15 centimeter from the converging lens. Two type of lenses are there. One is having the focal length of 25 centimeter. Second is having the focal length of the 20 centimeter. The distance between the diverging and the converging lens is 15 centimeter. Now, the question states that a beam of the parallel light falls on the diverging lens. A beam of the parallel light falls on the diverging lens. Then at what position the final image is formed? At what position the final image is formed? So first of all, I want to tell you all, I should give you all a data. The one that is a diverging lens. So I would consider the concave lens as the diverging lens, right? The second lens is converging lens. Sorry, this is a converging, this is a converging and this is a diverging lens. I'm sorry for that, right? The focal length of the diverging lens is 25 centimeter. The focal length of the converging lens is 20 centimeter. The distance between them, it is given as 15 centimeter. The parallel rays of lights are coming. The question states that parallel rays of lights are coming right to the diverging lens, right? Then we have to find out at what final position the image is formed, right? So I think without wasting our time, we should give you all a 1 minute to solve this question. Come on, everyone. Less than 15 seconds are remaining. Come on, everyone. Okay, so time's up. So depending on the data, let's draw the ray diagram first. Okay, so this is a solution that what we are discussing. This is a converging lens. Sorry. Okay, this is the converging and the concave lens is a diverging lens. This is a principal axis. PA stands for the principal axis. Now what happens here? Okay, here the focal length of the diverging lens, it is given as 25 centimeter. Okay, the focal length of the converging lens, it is given as 20 centimeter. Okay, now the distance between them is kept at 15 centimeter. This much data is given into the question, and with that it is also mentioned that the parallel rays of light are coming. See, one thing is for sure, if the parallel rays of the light are coming, okay, it means that object is somewhere at the infinity. There is a single possibility for a ray of light that emerge from the object, and that would be parallel. Okay, the possibility is if the object is kept infinity, then the rays of the light has to cover the quite large distance. And when they cover the quite large distance, obviously they becomes the parallel with respect to each other. So in this case, I want to tell you all of those lines are parallel with respect to this lens, and when they are getting incident, they are parallel. It means the object is right at the infinity, and from that specific part, right, from the infinity, the rays of the lights are coming. So the first step states that if rays of light are getting incident parallel on the diverging lens, it means that image is going to form at focus. Image will be formed at focus. Right? Image is going to form at focus. Yes, one thing is for sure. Image is going to form at focus. So should I note it down? Yes. The first image will form at focus, right? So it means that this image distance is going to be 25 centimeter, right? Like this way, the image will be formed at focus, right? Now, the image that has been already formed on the focus will act like an object towards the another lens, right? So it means that the first image we got it at 25 centimeter, negative 25 centimeter, right, with respect to the diverging lens. The first image we got it as negative 25 centimeter with respect to the diverging lens. Yes or no? We got that. Okay. Now what happens? Again, I'm going to draw this converging lens. Now the object is at approximately u. The first image that is formed, if the object is at the infinity, we all are aware that the image is going to form at the focus point, right? So here this would be the focus point on the left side of the lens. Why? Because it is a concave. Okay. Now this focus point at which the image is formed will act like an object, right, for the another lens that is converging. So now the object distance is going to be 25 plus 15. So that is going to be 40 centimeter in front of the converging lens. Now for this we have to again draw the ray diagram and find out where the final image will be formed. Okay, we have to find out where the, now here we are going to apply the lens formula. Applying the lens formula, right, what we get, 1 by v minus 1 by u, that is equal to 1 by f. V is equal to fu whole divided by f plus u. The focal length of the converging lens is 20 centimeter, right? So it is positive 20, negative 40, 20 minus 40, right? So the final image it is going to get at plus 40 centimeter with respect to the diverging lens. So it means that the diagram is going to follow like this way, right? This will be the final image, right? This will be the final image at approximately 40 centimeter from the converging lens. Okay. So this is the first part of the solution of the sum. This is the second part of the solution, right? And finally, the final image of this specific, it is going to form at the opposite side, right? So what will be the perfect answer? The perfect answer to this specific question will be the real and the distance. Okay, now why it is real? Why the image is real? Because the rays actually meet at the point. Okay, rays actually meet. Rays actually meet. So as of that reason, the image is real. If rays were above, tends to meet, then the image would be virtual. Right. So here, real image and distance of 40 centimeter from the diverging lens, wrong. 40 centimeter from the converging lens, and the image is real. Real and the distance of 6 centimeter, wrong. Real and the distance of the 40 centimeter from the converging lens, yes. C is the perfect answer for this specific question. C is the perfect answer for this specific question. Yes or no, guys? Okay. Now, let's move on to the next question onto it. And this is a very good question. The question from JEE in 2016, basis on the telescope. See, if I'm talking about the, first of all, I'm going to shut off the AC here. It is going to create an impact. Okay. If I'm talking about a very simple statement, right, the questions that are going to come up from the astronomical telescope, simple and the compound microscope. Mark my words, only two questions, two varieties of the question. The first one based on the magnifying power, the second one, right, on the length of the tube. These two kind of the questions are going to come up into an examination. So first of all, your base should be perfect on this, and then you can move forward. Right. So this is a very awesome question, right? Very nice question from the observer, this astronomical telescope. Now let's have a look. Let's look towards it. An observer looks at a distance tree of height 10 meter. There is one tree, the very large distance. The tree is at the very large distance. An observer is seeing through its telescope. The height of the tree, it is given as 10 meter. An object is performing. The observer is seeing through its telescope. The telescope is having the magnifying power of 20. The telescope is having the magnifying power of 20. Then to the observer, the tree appears as. Then to the observer, the tree appears as. See, it's a very simple question. Okay, but first of all, I'm going to discuss the data. Okay, see, this is observer. He is watching the tree through the telescope. Tree is at the very large distance. The height of the tree is given as 10 meter. Tree is at the very large distance. The height of the tree, it is given as very, right, is 10 meter. Observer is observing, this is very large distance. Now, the question states that if the magnifying power is 20, the data mention is, here is, that magnifying power is 20, okay, then to the observer, how this tree appears to the observer, right? So without wasting our time, I think we should give you all of 1 minute to solve this question. Come on. Huh. Okay, less than 10 seconds remaining. Come on, everyone. See, first of all, I want to tell you all, I want to ask you all, we were talking about the two different situations. If I'm talking about the actual formula of the magnifying power, then it is a ratio of vision angle when seen through the instrument to the ratio of the vision angle that is seen through the naked eye without instrument. And this is given as the 20. So as a solution, we are going to discuss the two different situations. The first situation states that, right, this is the tree, Okay, when observer is seeing through the naked eye, okay, the tree appears to be height of 10 meter. Again, the distance is very large, x. The first situation. The second situation states that whenever he is seeing with an instrument, this will be the height of the image that appears. Right. So can I say when he is seeing with the naked eye, the angle is theta 0. When he is seeing with an instrument, the angle is theta. This two situation we are going to deal. Now on basis of that, right, okay, this is a solution we are going to discuss. On basis of that, first, according to the definition of the magnifying power, as I said that it is a vision angle tan of theta with an instrument, right, without instrument it is theta 0. Okay, now what happens here? Tan of theta, if I am talking about the first situation, that is without instrument, and this is with instrument. So if I am talking about the first situation with the instrument, then angle is theta. So here can I say that tan of theta, here again the distance is x, very large distance, h dash by x. Why I have taken the very large distance as x in both of these cases? Because in theory we have taught, okay, the image may differ in between d to infinity, right? Okay, image may differ d to infinity, right? So here I want to convey a single message that the reason behind it, that in both of the cases we have taken the very large distance as the x. Why? Because the tree is actually at the very far distance. So we are unable to define that, so for that reason we have taken as the x. We are unable to define that, so for that reason in both of the cases we have taken as x. Right? So here tan of theta is x, and here if I am talking about tan of theta 0, then this is equal to h by x. So here can I say that it is h dash by x, and that is h by x. So gamma we are going to have it as h dash by x into h into x. The x is going to get cancelled, right? The magnifying power is 20, h dash by h. So h dash, that will be equivalent to 20h. If an observer is seeing the tree with an instrument, it appears to be 20 times taller. This h is the original height, na? The tree appears to be 20 times taller than its original height. The tree appears to be 20 times taller, right, than its, I'm sorry. Hello. The tree, I'm sorry for that. The tree appears to be 20 times taller than its original height, right? So let's check it out. What option states that 10 times taller, wrong, 10 times nearer, wrong. C is the perfect answer for this specific, right? Okay, the very awesome question. If you want to just note this down on the countdown of 10 seconds, if you want to just note down this solution, you can just pause this video and do, or else, right, we are directly moving forward to the next question. So I hope so you might have paused this video. Now let's move on to the third question. This is a theoretical based question, right? The question is asked in JEE Main 2014. Okay, the green light is incident from water to air water interface. Generally in maximum number of the questions, the kind of the data that we have, the white light is getting incident at the surface, right? And things happen. Whether the refraction, the total internal reflection or the dispersion whatsoever, right, phenomena is going on, but always we have deal with the white light. But in this question, in the question into the 2014, they have changed the data, and instead of white light, they have taken a green light, and getting the light is getting incident on the specific surface. But the thing is, it is getting incident at the critical angle. Select the correct statement. What does the situation states? See, this is a surface that separates the two media. This side we are having air, the refractive index of the air is 1. This side we are having the water. Okay, now let's draw the normal to this specific surface. The question states that let's take a green light. The green light is getting incident at this specific surface where the incident angle is the critical angle. Okay, the green light is getting incident at the specific surface separating the two medias, air and water. Green light is getting incident to the specific surface that is separating the two media, that is air and water. So what happens here, right? If it is getting incident at the critical angle, then what will happen after it? The 4 options are given in front. What will happen after it? Right? The 4 most important options are given in front. Right? So I think let's give you all a time minute to solve this question. Okay, less than 10 seconds are remaining. Okay. Yesterday's lecture, when we were discussing the dispersion of the light, in yesterday's lecture, when we were about to discuss, or not we were about to, but we have already discussed the dispersion of the light. In dispersion of the light, we have seen, if the white light is getting incident at the specific refractive index, we have seen into the simulation also, if the white light is getting incident at the refracting surface, right, from denser to the rarer medium, the light is traveling from the denser to the rarer medium, then at a surface it get dispersed into the 7 lights. That was Vibgyor. So at that moment into the simulation, you can just check it out into the yesterday's lecture, we changed the refractive index. And some noticeable observations we were having, and those were like, if we are increasing the refractive index, then the light was getting dispersed into the 7 colors. And if we were keeping the refractive index as a minimum, that is equivalent to the air, okay, then only the white light was refracting. So here what happens? Generally, whenever the white light gets incident on the specific surface, one thing is fixed. If the light is getting okay, if the light is getting incident on the specific surface at the critical angle, then it is going to, okay, after this, the light is going to graze the surface. This thing is sure. Why? Because it is at the critical angle. Okay. Now the question behind it is, which visible light of the spectrum will graze? One thing is for sure, that it is going to graze the medium, but which visible light will graze? That is an important part, right? So first of all, again I'm going to move back to the yesterday's lecture. I told you all there is some relation in the simulation when we were increasing the refractive index, right? Okay, then light was getting dispersed into the 7 colors. So when the refractive index was maximum, the light was getting dispersed into the 7 colors, and we were changing, or we were decreasing the value of the refractive index to the minimum, that is the refractive index of air. Okay, we were keeping the value as minimum. Okay, then what was happening? We were only getting a single light. So in that case, we found that there is some relation between the refractive index and the wavelength. So that relation is the refractive index is inversely proportional to the wavelength of the light. The higher amount of the refractive index, the lower amount. The lower amount, the higher will be the refractive index, the vice versa. Now, the second statement states that, right, we can't remove that point when the light is getting incident at the critical angle. So one thing is for sure, if the light get incidence at the critical angle, then we are having another one relation, that is sin theta is directly proportional to 1 by refractive index. So can I consider this is equation number 1? Can I consider this is equation number 2? From 1 and 2, can I say that lambda is directly proportional to sine of theta c? Lambda is directly proportional to sine of theta c. So this statement states that when the green light is getting incident at the specific surface, when the green light is getting incident at the specific surface, whatsoever the wavelength of the visible light having the intensity less than green will graze the surface. Less than green will graze the surface. Let's check it out, all of those points. The spectrum of the visible light whose frequency is more than green light, wrong. The entire spectrum of the visible light will come out of the water, wrong. If the entire spectrum is going to come, then these two reasons are going to get violated. The entire spectrum at 90 degree gone. Okay. Right, and the final thing, that is D will be the perfect answer whose frequency, see, the whatsoever the light that is coming out whose frequency is less than green, right, will come out. Okay, some of the rays will, the situation, exit situation will be like this way. Some of the rays are going to try to graze the medium and some of the rays will be into the air. Okay, some of the rays will be into the, right. So this is an actual situation. I'm moving aside at the countdown of 10 seconds. If you can just note this down, you can just note down this stuff. Okay, that much time is enough. Now let's move on to the next question. A thin convex lens made from the crown glass. That is generally, right, again I'm going to come back to my thought that whenever we are talking about the thin lens, then we are not considering the refractive index inside it. Right. So the thin convex lens that is made from the crown glass, that is having the refractive index of 3/2 and its focal length is f. When it is measured into the two different liquids, see, mark my words, one lens of the refractive index 3/2, it is kept into the two different liquids, right? And now they are measuring the focal length into the two different liquids. The refractive index of the first liquid is 4/3. The refractive index of the second liquid is, data error is there, it's 5/3. Focal length is f1 and focal length is f2 respectively. Then the correct relation between the focal length will be what? The question is asked in JEE Main 2014. The correct relation between the focal length will be what? See, what does the question states, right? It is comparing the three different things, right? I'm going to note down here. This is the first one, this is the second one, and this is the third one. I'm going to explain you all whatever the data that is given into the question. First, this is a lens, right? This is having the refractive index of 3/2 and it is kept in air. In this case, the focal length is f. When this lens is immersed into the fluid, right, the refractive index is 3/2 into the first fluid, where refractive index we are going to get it as 4/3, then the focal length is f1. The same situation, okay, Now the lens is immersed into the another liquid having the refractive index pi by 3. Refractive index of the lens is going to be same. Then in this situation, the focal length of the lens is going to come upon as an f2. Then we have to find the correct relation between f1 and f2. Right? We have to find the correct relation between the f1 and very nice question. In the thin lens formula, they have taken the reference, right? They have taken the refractive index and applied the lens makers formula. So let's move on to it. Okay, let's give you all a time to solve this stuff. Okay, so I think we should discuss the solution here only. Okay, so in the solution we are going to compare the three different cases. The first case, when the lens is kept right into the air, the refractive index of the air is 1, the refractive index of the lens is 3 by 2. In this case, the focal length is going to come upon as f. So applying the lens maker's formula within it, right? Applying the lens maker's formula within it, what happens here, right? Okay, 1 by f, that is going to be 3 by 2 minus 1, 1 by r1 minus 1 by r2. Now in this case, mark my words, this side the curvature is r1, this side the curvature is r2. But in question, the r1 and r2 values are missing. So we are going to keep it as a variable. Variable in this sense, we are going to just denote it, not variable, we are going to just denote it. So 1 by f, that is going to come upon as 1 by 2, 1 by r1 minus 1 by r of 2. Can I consider this as equation number 1? Okay. Let's move on to the another situation when the same, right, it is immersed into the refractive index. Okay, see again, this is immersed into the refractive index of 4 by 3. This is 3 by 2, focal length is f1. So 1 by f1, that is equal to, right, 3 by 2 whole divided by 4 by 3 minus 1 into 1 by r1 minus 1 by r of 2, right? So it is 9 by 8. So it is 1 by 8, 1 by r1 minus 1 by r2. If we are replacing this equation here, then we are going to have f1, that is equal to, right, 4f. Equation number 2. Okay. Now same thing we are applying for the refractive index, right, of 5 by 3. And the focal length is going to come upon as f2. So 1 by f2, that is equal to 1 by, 3 by 2 whole divided by 5 by 3, right, minus 1, that is 1 by r1 minus 1 by r of 2, right? So 1 by f2, it is going to come upon as negative of 1 by 10, right, that is 1 by r1 minus 1 by r of 2. Again, I am going to replace this equation in this. So you are going to get f2 as negative of phi of f1. In first case, we got it as f2 as, right, 4f. Into the second case, we got f2 as negative of phi of f1, not f1, but f. Okay. So suppose if we are analyzing the situation, right, f is f, f1 is 4f, f2 is negative of 5. On basis of this, we are going to select the correct option. f2 is greater than f and becomes negative. Wrong. Both f1 and f2 becomes negative. Wrong. f1 is equivalent to f2. Wrong. D is going to be the perfect answer for this specific question. D is going to be the perfect answer for this specific question. I'm moving aside. If you just note this down, you can just note this down, right? And the countdown of 10 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Let's move on to the next question. Okay, the question is very awesome and it's been asked in JEE Main 2013. I really appreciate this question, right? Okay, I really appreciate this question. Really awesome. Diameter of the plano-convex lens is 6 centimeter. Diameter of the plano-convex lens is 6 centimeter. The thickness at the center is 3 mm. Okay. First thing that is given, diameter as 6 centimeter. The second is 3 mm is the thickness. If the speed of the light into the material of the lens is 2 into 10 to the power 8. See how smart they are. They have not given the refractive index of the material. They have given the speed of the light into the respective medium. They haven't given the refractive index of the material, but they have given you the light into the specific material so that you have to find the refractive index. What will be the focal length of the lens? Okay, I'm going to show you all, don't get worried. Okay, see, first of all, it reminds me about the spherical surface from which the lens is made. The spherical surface from which the lens is made. Should I give you all a 1 minute to solve this question? Right? Should I give you all a 1 minute to solve this question? Yes or no? Okay. I think first of all, let's explain you all. This is a lens, the plano-convex lens. This is how it is cut. This is the radius of curvature of the plano-convex lens. This is the thickness T. So this part would be R minus T and this is D. This entire situation is all about, it is mentioned into the question. What we have to calculate? We have to calculate the focal length of the lens. Okay, so let's give you all a minute. Okay, this sum we are going to solve, right? This sum we are going to solve into the very simple manner, right? Suppose if we are applying the Pythagoras theorem, things are gonna get awesome, right? Okay, so it would be hypotenuse is r square, that is d square plus r minus t whole square. So on rearranging the terms, I am going to get r square minus d square, that is equal to r minus t square. Keeping r common, so it is r square minus d square, that is equal to r square 1 minus t by r whole square, right? So again, r square minus d square, that will be r square 1 minus t by r whole square. So it is r square minus d square whole divided by r square, that is 1 minus t by r whole square. Now here the thickness is in mm. So it is very less than the radius of the curvature. The thickness is in mm and it is very less than the radius of the curvature. So here we can apply the binomial theorem. In physics, how to apply the binomial theorem we all are aware of, right? Okay. So on applying the binomial theorem, this will come up here. So we are going to have r square minus d square by r square, that is equal to 1 minus 2t by r. So this is going to be 1 minus d square by r square, that is equal to 1 minus 2t by r. Okay. So this is going to be r square by d square by r square, that is equal to 2t by r. 1 r is going to get cancelled and r is equal to going to be d square by 2t. On replacing this value, you are going to get rs plus 15 centimeter. This will be the radius of the curvature of this lens, right? This will be the radius of the curvature for this specific lens. Now let's apply the, now we are not aware of the refractive index. Refractive index is speed of a light to the medium. Now the speed of the light is 3 into 10 to the power 8. Medium 2 into 10 to the power 8. So the refractive index of the material is 3 by 2. Can we apply the lens maker's formula to find out the focal length? Yes. 3 by 2 minus 1, 1 by R1 minus 1 by R2. Again a new twist. In the Plano-convex lens, we are having only the one curvature. It means value of 1 R is known, second term will be discarded. Right? So here 1 by F, that is equal to 1 by 2 into 1 by R. So the focal length, it is going to be the 30 centimeter for this kind of the lenses. Right? Focal length is going to be the 30 centimeter for this kind of the lenses, and the B is the perfect answer for this specific question. Right? If you want to just note this down, you can. The countdown off. So students, it was all about the ray optics. Okay, I think it's time to go. Again, we're going to come back tomorrow into the next chapter, that is of the wave optics. The next session will come. Okay, so thanks a lot for your cooperation and your time. This is your own physics educator Indrajit Singh signing off from the desk. Bye bye, Sat Sri Akal and Namaste from my side. Bye everyone. Stay at home, stay safe, stay healthy amidst this pandemic, and take care. Bye.